our day 7 session. And today we're basically going to talk about storage in smart contract. So how Near avails the functionality that you can use to store your data, or persist your data in this case, on its blockchain. Now, what you're going to need for this particular session, the tools you're going to need are what you already have: the Rust WebAssembly toolchain, the Near CLI, and the testnet wallet address or account. And what you're basically going to cover for this particular session is going to be on Near storage or Near storage collections. And the second item is going to be storage staking. So we're going to learn how all these are going to come into play as we proceed. Great. I hope you can see, you can all see my VS Code editor. I'll just increase the font. Great. So here we are. We're going to, again, I created a new project. So npx create Near app. Then I passed the contract flag to be Rust, and I named our project. Then the folder we are apparently working on is the contract folder of that project I created. And within our lib.rs file, you realize that I've made some very few changes just to ensure that we capture what we want to cover in our today's session. So we're also going to look at all these functions right here and basically see how the storage concept is going to unveil. So let me just have some placeholder right here. Great. So I'll be talking about these functions. For now, don't be worried with what's actually going on. So again, I'll be going through all that as we proceed. Let me just minimize them all for now. Great. So let me just share my browser for a moment. Let's cover something on storage, on Near storage, and what is basically in place for us. So I'll just go ahead and search for Near docs, for Near documentation, hit on the first link. That should redirect us to Near's documentation page over here. And like I said, we have quite a bunch of directions you can take. So for now, since you're working with the Rust, I'll just hit on the Rust documentation, and that is going to redirect us to Near SDK.io page where we were yesterday over here. Then I'll just come here and try and search for storage, see what this is going to give me. Okay, it's nothing. Not finding anything. Let's try and find it back here. Okay. Great. So yeah, this is the page I wanted. So I'm just going to share this link in the chat, guys, from your end. Now, when you follow this link I've just shared with us, it gives a detailed description on how you can go about data storage, or in this case, persistent collections on the Near protocol blockchain. So there's a very extensive description that has been given in the page. The very first section talks about assembly script collection types. So like I said, we have two programming languages that you can use when doing your smart contracts in Near protocol blockchain. So the first one is the first one you can use is assembly script. The second one is Rust, which is recommended for real world projects. And since you are using Rust, we won't really tackle the assembly script section of it. So I'll just scroll down to Rust. In this case, where we have over here, the Rust collection types. Maybe I can as well push this in the chat so that we are all at par. You don't have to do a lot of scrolling. Just takes you direct to that. Great. So here Again, all these are going to be availed in the NEAR SDK RS library, what we are using in our smart contract. So now, here are some of the data structures that have been availed by the NEAR protocol blockchain to us as developers, which we can use to persist data within our smart contracts. So look at them like the databases we are going to use, or the database engines we are going to use within our smart contracts. Now, while writing your smart contract, there's nothing like SQLs. There's nothing like NoSQL. So the likes of Mongo and all that, no, we don't have that in blockchain. So in blockchain, we basically have specialized data structures that are basically going to help you persist your data in the blockchain. And so when it comes to the design of your smart contract and the general system you're trying to realize on the blockchain, it's very good for you to have a very good grasp of what these data structures do, how they do them, and their efficiency. Because there are some operations you may want to do or achieve within your smart contract, and a particular collection is best fit for that. All right. That's why I'm trying to take us through this. So we have quite a number of them. We have vector, lookup set, an ordered set, lookup map, an ordered map, and the tree map. Now, this table gives us a sort of a summary of what each one of them does and how they perform. So the very first column was the type. That is the type of collection that I've just mentioned. Iterability or iterable, clear all values. So the second column is indicating whether the type of collection in question is iterable, or you can loop through its content. Okay. Then the third column, clear all values, is basically indicating whether there's a function available to us that we can just use to clear all the values within the collection. The fourth one is preserves insertion order. So are you only able to append a data at the end of the data structure, or there are some functionalities you are able to, specify the index where you want that data to be inserted. The range selection. So at this point, you're basically able to select a range of values within that particular collection. Now, let's start with the vector collection. Vector is a persistent data collection that is iterable, or you can iterate through its items. And in this case, this is going to be the type. So it's kind of similar to what we have in Rust standard library collection, but with some added functionality or performance. So you can iterate through the values of a vector, but you can't iterate through the lookup set values. You can iterate through an ordered set items, but you cannot iterate through lookup map items. You can iterate through an ordered map items, but you can as well iterate through the tree map collection. Great. Now, when it comes to clearing all value, you can as well clear all the items in a vector collection. You can clear all the items in an ordered set collection. You can clear all items in the unordered map collection and tree map as well. Now, there's something I want you guys to note when it comes to clearing items or performing all these operations that we're talking about on blockchain. Like I said yesterday, that every operation you're going to conduct within your smart contract is going to require you to attach enough gas for you to be able to do that. Now, assume that our vector in this case, the array where we're going to basically store our items, has thousands of items, or tens of thousands, or hundreds of thousands of items in it, right? Then you avail a function that is going to clear all those items. It means that if you're not going to attach enough gas for that particular transaction, then all that you won't be able to achieve that. The function is there, yes, but the amount of gas determines whether it will be executed or not. So if you're going to attach less gas, but then you want to clear all the values in your collection, then that won't be possible. So that is just something to note when it comes to doing all that, all the operations that we're actually going to do using our collections. Now, preserve insertion order. That ability is available in vector, and selecting a range. So you can basically specify where you want to start getting your items to a certain range. The vector collection, an ordered set collection, and an ordered map collection will basically help you do that. However, the rest have no capability for that. Now, in this section, we are going to measure with two. I'd call them two major collections or persistent collections in near protocol blockchain, in doing your smart contracts in the near protocol blockchain. And these are the vectors, or the vector collection, and lookup map collection. So you realize that the vector collection sort of has a check for all these operations we have at the top here. But then our lookup collection doesn't qualify in any of those. So we're going to, let me just expound or hint on the difference between the two. Our vector, like I said, is going to store your items in sort of like an array, okay? So your items are basically going to be stored in an array type kind of data structure. So in an array, you could basically loop through the items, right? And you could as well specify the item you want to get the value of, or the item you want to retrieve from the vector by specifying the index of that particular item. So all that is possible. However, when it comes to lookup map collection, here the storage of data is a bit different in that if you have a value that you want to store in this particular collection, then you'll be required to give a key that this value is going to be stored under, or this value is going to be attached against within the collection. And the key you're going to issue is what is going to serve as the index that you can use to retrieve the value. So let's say I wanted to store an object student in the lookup map collection. Then I say that I'm going to use the student's ID as the key to the student object that I'm going to store within the lookup map collection. So it means that anytime I need to retrieve or access the student object, I'll be required to have what? The student ID. So once I indicate the right student ID, there I'll be able to get, that will be matched to the value that was stored under it, okay? However, if I provide something incorrect, then I'll not be able to get the right value I was looking for. Something else to note is you can't loop through the items in a lookup map collection. That is not possible. You cannot do that. So if you wanted an item, you must remember or be in possession of the right key for that particular object, okay? Let's move down here, and there's another table, very good table down here. Now this one talks about time complexity and space complexity. I hope you guys have come across those terms. So these are basically for efficiency of these algorithms, depending on where you want to use them in your smart contract. Now, right here, there's some big O notation, and this one is describing time complexity. Basically, how long a certain collection is going to take to run a certain functionality. Now you look at the vector, or you consider all these collections that have been listed here. If you wanted to access an item in them, this is the big O notation. Sorry, the access column, all these values indicates the time complexity of accessing a value. When it comes to inserting a value, it also explains that. Deleting an item also explains that. So again, you're looking forward to, craft or develop efficient smart contracts. And like I said, everything you do on blockchain, you have to pay for them. So if you're going to come up with a smart contract that is going to, make use of expensive operations, in this case, if the time complexity is going to be, big, then it means the users of that particular smart contract are going to be expected to attach more gas or use more money for that particular transaction. So if you are a developer and you're looking forward to develop efficient softwares that are going to minimize on the gas cost, then it's very critical for you to look at this table before you make any use of these collections, okay? So all that has been listed there. If this is your first time coming across the big O notation concept or time complexity and space complexity concepts in algorithms, you can as well do some research on that, and you'll get a good explanation of what that is. Now let's move down here. There are some other charts right here that are basically expounding or sort of giving us some graphical representation of what we've just looked at in this table. So the time complexity table. So down here, you're given a visual representation on what happens. And let me make use of this middle, the first row middle item or middle graph. It is giving us a data on the gas burnt, adding data to this particular unordered map collection. So here you see how gas is burned compared to other graphs while adding data to an ordered map collection. So here we have a lot of gas burned compared to this and compared to this other one. So the first one, the value is constant. The second one, the value is constant, but higher than the first one, the first graph. Then the last graph in that row is basically the more the data, it's sort of the more the data, the more the gas you need, the more the data, the more the gas you need, and all that. So you can as well have a good look at this through the link I've just shared. It's very, very important for you as a developer. Now, like I said, if you as well follow that link, you're going to get some more description on about these particular collections, but I won't be touching on that now. I'll just head on to our VS Code and see how we basically are going to implement this within our smart contract. Okay, so we're going to talk about all these. This lookup map giving you how to add data and how to get data and all that. Okay, so let's head on to our VS Code and see how we basically can be able to achieve all these functionalities in our smart contract. Awesome. So we are back to our, yes, someone has their hand up. Jerry?
I had a small question.
Okay.
The difference between lookup map and hash map, is there a difference in how we implement them?
Look, okay, hash map is Rust default collection, right?
Yeah.
Yes. Then lookup map is a collection that is coming to us through the near SDK library. Now, the difference is actually in performance. Maybe if we can head on, if we can head back here again. I don't know if I'll be able to find the link. There's a link that actually gives the differences between the two. Yes, so here's the link. I just found it. Let me share these with us as well in the chat. Great. So The question you've just raised, Jerry, the question you've just raised has an answer right here. Okay. So this structure behaves as a thin wrapper around the key value storage available to contracts. And the structure does not contain any metadata about the elements in the map. So it is not iterable. Now, their functionality is basically the same. Okay. However, the lookup map that is available to you out of the NEAR SDK library is quite optimized for blockchain use cases. So it's not as general as the normal hash map, okay? And the lookup map will store its data. Now, if you use a hash map in your smart contract, it means that once someone invokes a function or your smart contract object is loaded into a computer memory, then all the elements within the hash map are also going to be loaded in the computer memory. And that is really going to be expensive. Okay. Now, lookup map has been optimized for blockchain use cases such that no matter how many elements or items you stored in the collection, while your program is being loaded into the computer memory, and now these the computer memory of those who are running the network, okay, the nodes in the nodes. So once it is once your computer program is going to be loaded into the computer memory. Sorry, when your smart contract program, sorry, is going to be loaded into the memory of the node's computer, then your lookup map collection will not be loaded into the computer memory. So it means it will have saved on time and space. So the gas associated with that particular transaction will be less compared to what is going to be associated with if it were a hash map. Okay. So again, the main difference between all these is optimization for blockchain use cases. And that page explains quite well why we have all that in place. So just follow that link and you'll be able to get my explanation on that. Okay, Jerry?
Yeah, thank you.
Okay, great. So let's head on back to our VS Code. Just go to our VS Code right here. Sorry. Yes. So like I said, I created a new project. Then I basically did some few customization over there. So we're going to build this from scratch in this session and see how things are going to unfold. Now, the very first thing we're going to talk about, let's look at lookup map. Sorry, let's look at lookup map. Then we're going to come back to, or we're going to look at vectors afterwards. Then from there, we'll be looking at storage staking, or what storage staking actually means. Okay. Now, I'm going to go ahead and avail a property to our contract structure. And I'm going to call this property students. Okay. So the property students is going to be of type lookup map, which we're going to import from the NEAR SDK library. And it is going to, the data type of the key we're going to use in this particular data collection is going to be of type string. And the value is going to be of type student. Now we're going to create that in our project. So let's go ahead and create this student type or student structure. I'll just come over here and create a new file. I'll call this students. Then over here we're going to have a public structure, public struct student, that is basically going to contain our student what? Properties. So a student is going to have a name of type string. A student is going to have, what else, guys? A course. Course is going to be of type string. A student is going to have a year, right? Let this be of type U8. Where is that? Right. Well, let's use U32. Then a student can as well have age. Yeah, student can as well have an age. So this one is going to be of U32 as well. Great. Now, this is the name of the student, the course the student is taking, the year in which the student is, and the age of that particular student. So that is basically it about our structure. And like I said, I think sometimes in one of our previous sessions, that most of the structures we're going to use within our smart contract source code are going to take this macro, so the near bindgen macro. That is what I've just brought in. Then I'm also going to use this other one, Bosch serialize and deserialize, and Bosch deserialize that way. Then I'm basically going to bring all these in. I'm going to basically import them over here. Then I'm also going to bring in the near SDK, near bindgen. Great. Yes, so that should be good to go. Though we're also going to make use of the JSON serialization. So when time comes, I'll be showing us how we can go about that. Now, I hope I can now bring this one in. Still not coming, so let me just come up here. See if I can bring students. Then use students, student. Great, so that one just worked. So we brought in our student structure within our lib file. Then I'm going to implement some default, to put some default implementation. So I'm going to say students, if our program will not have been initialized, then this is where we're going to do the initialization, okay? And we're going to assign our student property, and we're going to give it lookup map, which is going to take, lookup map, then invoke the new function of that. And we're going to give this a very unique prefix. Let's call this S. Let's give it S for student. And again, I think I came across this while you were doing the search. So there's a reason why we are using the prefixes. Like I said in the other session, we use them to give unique identities to our what? To our collections. So at this point, we have a lookup map collection, which we are storing as in the student's property or student instance variable in our contract structure. So this is basically going to act as a database, or a database that is going to contain the student information. So we could come down here and still have another structure called these courses, right? Then courses can as well be another what? Courses can as well be another lookup map data structure we are using within our smart contract. Now, to keep some difference within our smart contract, that hey, this lookup map is different from this other lookup map you're talking about, then we give them these prefix strings or characters for use to bring in the difference. Now, these are going to be uniquely identified within our smart contract, and you're not limited to just using one character. You can use as long as a long string as you want, but take note of the storage cost. So the more this string is going to be, the more the storage space it is going to consume. So again, it boils down to how much you're ready to pay for that particular storage. So that's why Usually we use single or characters to basically give the differences. So for now, I'll just undo the courses property like that. Then we're going to proceed. Great. Now, my student file is already complaining over here. Let me see what this is giving me. So conflicting implementation of trait for type that. Okay. I don't understand what this is trying to say. Oh, so I'm having deserialize twice. I think I need to bring in serialize, right? Great. So that basically takes away the error. Good. So let's head on back to our lib.rs file over here. And now we're going to look at how we can add an item to our student collection or student data structure. And that is the first function, the very first function we're going to look up. So to add data or to add an item to our data structure, let me just have some parameters added right here as well. So like I said, we're going to expect the student to give us all this information, the name, course, year, and age. So that is what I'll basically add right here, the name, the course, the year, and the age, right? Then using all that parameter, which we're going to expect the user to provide while invoking this particular function, we're going to use that to create a new student object. So let's just go ahead and do that. So student is going to be student, and our student has a name, which is going to be name. Our student has a course, which is going to take the parameter course, and the year, which is going to take the parameter year, and an age that is going to take the parameter age. Now, if you're so keen, let me just terminate this. Good. Now, if you're so keen here, the field name of structure of our student structure is private. It is a private field. So again, for us to be able to, now you could use the new function, guys, that I showed us previously. But for now, because you're also going to use this very same object to retrieve this information from blockchain, let me just make all these properties public. Okay. Let us just have all these public like that. And so the error goes away. However, now this is going to be of type student. However, there's still some line. If you keenly look at my properties, the name, the course, the year, and the age, and this one is saying there could be a shorthand structure initialization for this particular operation. Now, this is the same thing Json suggests to you if you're coming from JavaScript background. So instead of having name attribute and then the name value, you could simply use the word name to capture all that and organize it in a JSON object. So that is basically the refactor I'm going to make right here. Okay. And now our code is going to look quite clean and simple. Now, up to that point, we have the student object. And now we want to be able to now store this particular student object in our students collection. And remember, our student collection is a lookup, is of type lookup map. Okay, so it means we'll need a key for us to be able to store this particular value in that student's collection. So what key are we going to use? I'll come right up here, and you're going to use the signer key or the signer wallet address. So whatever wallet address is signing this transaction is what we're going to use as the key to our what? To our collection. So I'm going to get this using the env module, and I'll just do predecessor account ID. So that is basically going to give me, this is going to get wallet address. Then over here, we are basically right here, we're basically defining student object, or we are creating, I think that fits well, creating student object. Then down here, we are going to now store the student object. So student object. Now for us to be able to store this, we'll access our student collection through self, or self students dot. There's a function we're going to use to be able to insert this object in our collection, and that is insert method. And insert method requires a key. In this case, what we're going to use, we're going to use a assigner key. And then the value is basically going to be the student object we just created. Okay. So if that was successful, now I think I need to use some references here, right? My signer is taking their type account ID. I think that is where the conflict is also coming in. So if I can get this, then I'm just going to make this change, guys, within. So instead of our key taking type string, it is going to take type account ID. Then I'm simply going to make that change down here as well. Now I hope I'll be able to do this and do it here as well. So this one is taking a reference to our objects. Now, this line of, let me just do away with this to do macro for now, because we implemented the function body. Great. So that is how our function looks like. In this case, we've been able to implement how we can be able to add data to our lookup map. So in this case, to our students collection. Okay. Remember, we are using the key, the wallet address, or the signer of this particular transaction. And that is basically it. Now, let's move on to getting items from what? Our students collection, or in this case, our student data, student lookup map. Let me just do away with that as well. Now, to get this information from our students collection, remember we used the wallet address, or the signer's wallet address, as the key, all right, to the items or the objects we were storing in our students collection. So it means we will need that key for us to be able to do what? To retrieve that information. That's why the very first thing I'm going to do at this point is get the signer wallet address. And again, I'm going to use the env module to get that particular information. Great. So I think the comment looks the same with what we have up here. Just copy that down here. And after doing that, I'm now going to retrieve student object, which was stored against this key within our students collection. Okay. So down here, we want to, let's use the match, because up to now we are familiar with these match statements from our last sessions. So I'm going to use the match keyword or control structure. Then I'm going to access our self students. Then I'm basically going to get. Okay, why is that the case? Match solve dot students dot get, and you're basically going to pass the reference to a signer. Then missing match arm, so let's give it some arms. So if in the case that it found the student object, it is going to be returned in our first case. And here is how we represent the first case. So we're going to do student. And that is going to be of type should be of type student. So let me just do some operation over there. We can capture that within curly brackets. Then in the case that it is none, we are basically going to return invalid key, right? So I'm going to use, okay, let me just send that way. I'm going to use env module to log some string right here. So I'm going to log that message. Okay. Now, right here, in the event that we found our student, or if this key actually contained a student object right here, right, we are going to basically return it. Okay. So right here, we'll basically return this value to our to the user. Okay, then I'll specify that return type right here as student. Now this guy is going to complain. Now for us to be able to go about that, let's use this enum. Let's use the option enum. Then wrap our student object around that. Then right here, we're basically going to return some student. But if nothing was found, instead of logging this out, we're going to return none. Okay, so that way we're able to go about that error. So that is basically how we retrieve items from our students' lookup map collection. I really hope that is clear. If you have some question on that, please feel free to raise them. Now, how do we remove down here? How do we remove an item from a lookup map collection? That is basically what we're going to look at down here. Now, for us to be able to remove an item from the lookup map collection, again, we'll need the key, because anything we're going to do within the collection will require the key. So the very first thing we're going to have to do is get our key, and I'll just bring these down here. I think I'm lazy to retype all these all the time. So after getting the wallet address or the key, then down here we can now remove student object. And to remove the student object, we're going to need a mutable self object, because we're going to make some changes within our object. So right here, I'll do self dot students dot remove. Then my remove requires the key, right? So we're basically going to provide that. Yes, I think it needs a reference to the key. Let me just do the change right there. Awesome. So that basically removed that object or that item from our lookup map, our student lookup map project, collection. So now let's see what this remove function does. It removes a key from the map, returning the value at the key if the key was previously in the map. So it means it is going to remove this value from our student collection. Then it is actually going to return the value to us. Okay, so we can as well capture that in a variable. Let's call it student. Then after removing that particular value from our collection, we're just going to return it back to the user to basically notify them that, hey, here's the object that you actually removed from the collection. So I'm just going to return that as an option of type student, like that. Then down here, I should be able to basically do student. Okay. Okay, great. Awesome. So that we've been able to remove an item from our student lookup map collection. Now we're going to see how we can search or establish that a key exists in what? In our lookup map collection. So in this case, our students collection. Okay. So in this function, so after this, we're just going to build this, compile it down, and be able to test what we have so far before we proceed. So let me just do this as our last item. So again, I'm going to need these bits. Let me just copy these, then paste it right here. Because again, we're going to need the wallet address for us to be able to make this search. I want to make this a bit different. So, okay, I want to make it flexible. So instead of us capturing this wallet address, okay, let's accept it as a parameter. So this way we are able to search for, different wallet addresses in one, from one point, okay? So let me just see, let me capture this account ID, which is going to come in as a string. Then that is basically going to serve as the wallet address in this case that we want to search within our collection. Then down here, we're now going to search for that particular key, search for the key. Now, in this case, our key is the account ID that is going to come in as a parameter from the user. And for us to be able to make this search, we're going to make use of the self. So let me just do something here. Let me do an if statement. So if self.students, in this case, our students collection, contains, so if it actually contains the key account ID, in this case, we're basically passing in the account ID that the user has brought in. In that case, we want to return true. Okay. So we basically want to return, or we can return, should we return the object? We just return that. Come on. Let's have this as a reference. Good. So for now, let's just return a Boolean value. Let's make it simple. But you can choose to return the object itself, guys. You're not bound to doing this my way. Else, so in this case, if our collection do not contain the account ID you just specified, then we want to return false. Okay. And my account ID is still complaining. There's a mismatch. It expected this. Okay.
What data type is the key supposed to be?
Account ID.
An account ID.
Yeah, it should be account ID. I don't know if you can as well just capture that rather than giving me headache here. So let's try this out.
Yeah.
Let's see if this is going to work. So we just provide it as it is over there. Great. So if it is going to find a value or a key, in this case in our student collection, then this will evaluate, sorry, this condition will be true and will basically return true, else will just return false. So that is basically what's happening there. Now let's go ahead and compile this down and see if how this is going to unfold. Now I brought in our famous or our usual scripts folder, and I'm going to use this to build our project. Now, again, I mentioned this in our previous session. I don't have the RES or the resource folder, so I just went ahead and created that to put that in place for our build command to run successfully. Then our setting.config let's make use of our C4. Oh, sorry, C4 Sankore, the wallet address we just created the other day. Then you're going to create a sub account grid, so it will just default to all that. Now, let me first of all give some permission to this folder to execute the files in it as script files. So that should do the magic. Great. Then I'll just go ahead and now run our build script. And let's see what this gives us. Everything is going to compile well. Well and good. If not, we're going to see why. Yes, Jerry, you have your hand up.
Yeah, I'm asking which folder are we giving permission?
The scripts folder, this one here. It is containing our script files. So I'm on Linux, and in Linux, you have to give your script files permission to be executed. Yes? Jerry, you're saying something?
So if you do not give them permission, it throws.
Yeah, they won't be able to execute.
So if you do not give them permissions, it throws errors.
Yeah, sure.
Okay.
Yeah. Awesome. So I'm having some error in my file or in my project. The trait serialize is not implemented for student. Now we're going to need our student structure to implement the Json serialization trait. Okay. So again, I said we're going to see how we're going to make use of that. So that is basically what you're going to do. So let's see how we can do this. Let's see how we're going to make use of this. Okay. So we're making use of this macro because we are using the student structure to sort of bundle our output. And outputs by default in the NEAR protocol smart contract is sort of bundled using the JSON serialization and deserialization mechanism. So if you wanted to use Bosch by default, there's a way you can configure that within your project. I'll be sharing a link with us later on how you can do that. But for now, the default is JSON. So that's why we're going to need this. I'll just bring it in our student, and I'm going to put it right. Let me just have this minimized a bit. Good. Then I'm going to have it right there. So this one is a SAD, which I think I need to bring in as well. Just imported that over there. Then this one is specifying the trait, that our crate for this particular structure, we're going to use the NEAR SDK JSON serialization and deserialization. Yeah. So we need to add serialization, serialize and deserialize over there as well. Yeah, so that one now works. I think we can do away with this for now. Great. So that one bundles our structure as required now. So we're going to go ahead and give this a try again. Going to build it again. And great. So that one just built successfully. Let's go ahead and deploy it now. So I'll just go ahead and run our deploy script. So deploy. So first of all, we're deleting our sub account, creating it again, saving the key. And we were unable to deploy. Why? Because I think we never provided the right there, right? Now you realize that our WASM file is named storage, but here we have context. So let me just go ahead and make that change right there. Then this time round, instead of running all these, the first two commands, because this one ran successfully, I'll just comment them out so that we'll be able to run the last one, which is going to deploy. So it's starting to deploy. And boom, it's done deploying. Good. So let me just go ahead and comment these for now. So we've already deployed our smart contract. Close that. Head on to our call script right here. Let me do away with all these data so that we start from scratch. Now, right here, we're going to back to our lib.rs file. We basically have 4 functions we're actually going to execute at this point. The very first one is going to be it's going to add item to map. We just call that now map. Or let's say add student, get student, then delete student, and search student key, something like that. Then I'm going to have these as comments, basically to guide us through. Great. Now, you realize, guys, just with these, with whatever you can see, if you're coming from the Web 2 background, there's this acronym, CRUD. So you create, you read, you delete, and do create, read, update, then delete. Now, in our case, we've not captured update, but it's the same thing as adding, so creating is the same statement you're going to use to update. So while updating, you still will need to use, if I can find this, you'll still use line 51 to do the update. Okay, so the statement is just the same. So that is basically what we are trying to achieve in our call or on blockchain. Let me just go ahead and call this. So we're going to do near call, then bring in our sub account that way. Then our functions, so in this case, we're going to invoke add to map function. We do with the student thing. So that is the function. Our function requires some parameters, right? So let's give it the parameters. The very first one is the name. Let me call this Jerry. Now, Jerry, we're not going to give real data, so don't worry. Course is going to be computer science. Then we have year, right? Jerry is in year 4. Then let's have age. Jerry is very old, 75. Great. So, guys, remember I'm providing the variables. I don't know if I can have this go. Great. So we're providing the variables as they appear in our function signature. So the parameters. So the parameter name matches what the spelling we have in the name. The parameter course matches the spelling we have right there. And the parameter year matches, year and age matches what we have here and here respectively. Okay. Now age is a value, not a string. So let me just get rid of that. Should be a value. Great. Now, right here, we need to sign this particular transaction, right? Because you're using env module. So let's go ahead and do that. Do account ID. Then specify the account ID going to sign this particular transaction. That is how we do it. So let's go ahead and give this a try, guys. From our terminal, I'm going to call or to execute the call script. Let's see what this is going to give us. It should return an empty string. because that function actually doesn't return anything, doesn't return a value. If you're keen, where is that? Yeah, it doesn't return a value. So that's why we have the empty string. So it means the empty string basically means that, hey, our transaction was successful. Okay. So now that our transaction is successful, let's go ahead and get the object we just created, right? So let me just copy this function name as it appears in our smart contract. Come down here and do near call. Then you're going to call a smart contract that was deployed in our sub account. The function you're going to invoke is that. Does our function need any parameter? No. So we leave it blank, but then we have to sign it. So we do account ID. Then we basically pass the account ID that is going to sign this particular transaction. So we pass that as captured there. Now I'm going to comment this out so that we just concentrate with the get student command. Let me head on and clear my terminal and execute the call script again to run our get student command. So this time around, we expect it to return an object of student, and that is exactly what you can see in your terminal, okay? In my terminal, from my terminal, rather. So we created or we stored a student object, and the name of the student was Jerry. The course was computer science CS. The student was in year 4 and the age was 75. So that is basically what has been returned back to us. Okay. So that is how that went on. Now we're going to move on to, let's move on to the other function. I think I should be minimizing this as we proceed to create some space. Great. So let's move on to the next function, the remove function. So in this case, we basically want to remove that particular record that we added. Okay. So let's go ahead and see how we can be able to achieve that. So I'll just do near call. I'm going to call, a contract that was deployed in our sub account. The function is remove from map. It doesn't accept any parameter. We can confirm that. Good. Then we're going to sign this transaction using, now I think I'm going to use the wallet address I'm using to sign these transactions is quite repetitive. So let me just store that as a variable. So I'm going to do this. Let me call this signer, right? Then give it the value Paul testnet. So our signer, so a bit over there. So this signer is going to be called within our smart contract as a variable. So somewhere down here, let me just minimize this. Somewhere here, using the dollar symbol. Good. So that should do it. Then I'm just going to comment this out for now so that we concentrate with our delete student command. Then bring up my terminal again. So this time around, we're going to remove that record. Let's go ahead and execute our call script to execute this particular command right there and see what it's going to give us. So it went ahead and removed the student object under the key polotieno.testnet. Then it basically returned that object back to us. So if you're keen on our remove function, it was returning an object. So it can either return student object if it actually found the key in our student collection, or none if it never found that. So that's why we are sort of wrapping this up in an option enum. Now within our call, this was deleted. And now if I try to get the value again, we should get a null or a null value or something empty, right? Because it no longer exists. So let's just go ahead and try that out. I'll comment that out. Then I'm gonna uncomment the get command. Then I'll just replace the polytable with our variable, or assign a variable. Then from there, let's go ahead and execute this. So like I said, it should return either null or an empty object because it no longer exists. Okay, great. So you realize that now it is returning null because it didn't find anything or any value under that key that we provided, in this case, the signer address, wallet address. Great, that is basically it about that. Let me make this change as well up here. This looks neat to me. Let me make it right there as well. Let's now go ahead and search for the student key. Now to search for the student key, we're going to do near call within our sub account. Let's go ahead and invoke this. Where's that? So let me go ahead and minimize this and invoke the search in map function. It requires, this one requires a parameter. The parameter is named account ID. So I'll just copy that over, then provide it with an account ID. Let's call these anything c4.testnet. So this wallet address doesn't exist within our collection, but let's go ahead and see what this is going to give us basically. Okay. Now this function basically reads the state of the blockchain, or the state of our smart contract. So we don't need to sign that. It can be a view function. Okay. That is basically what we did over there. Then I need to comment this out. Let's see what this function executes to. Let's see what this is going to. So you realize it is giving us false because it was never found. Okay, that value was never, that key didn't hold any value, or it was never found within our collection. Now, if I go ahead, let's just perform the add operation first so that we have some value within our collection to work with. Let me just add that. So at this point, we're going to add a student object under the key, the wallet address we are using. Then from there, let me just have this commented out and now try and search for that key, but this time around, passing a valid wallet address that you are actually using. So polytable.testnet. Then let's go ahead and execute this. Now this one should give us a true. Okay, true because there's an object stored under the key polytable. Okay, so that is basically how that works. I can see time is already not on our side, so I'll try to be a bit fast, guys. Great. So right here, that was basically it about the lookup map. So let's go ahead and see how we can go about vectors. Right now, in vectors, we're going to create let's create courses. A course is going to be of type vector. So again, this is coming in from near SDK. And I think I should initialize this up here first. So let's have courses of type vector. And a vector is going to hold data or items of type course. Okay, again, we're going to create that. So let me just go ahead and create another file. I'm going to call this course.rs right there. Then for simplicity, let me bring in what we have in our student to save on time over here, like that. Then I'm basically going to change our structure name to course with some properties. So a course is going to have a course name, right? Course name, which should be a string. And let's just work with the course name for now to make it simple. So we have the course name. Let me just bring this in. Up here, I'm gonna do mod course. Then down here, we're gonna use course. Good. So just brought in the data type. So the error has gone away. Then down here, we initialize our vector using the new function, give it a prefix. Let's name this, let's give it C to make it simple. And terminate that. Hey, this is still giving me an error. Oh, this is courses. And yet I'm using course right there. Great. So that one took away our error. Coding can be at times frustrating. Yeah, so that error just went away. So we're going to now head on to how we can do some operations using vectors. I said vectors stores these in an array. Okay, so it's basically going to add the items you're going to make use of, or the items you're going to add are going to be stored in an array format within our smart contract. Okay. Now let's go ahead and add an item. So basically add a course, right, to our vector, to our courses vector collection. So we're basically going to need the user to provide us with a string and name. And after providing us with the name, we're going to basically create a course object. So a course object, which we're going to use our course structure to create. So our course basically needs the name. So that can come in as a name, right? What am I writing here? So that is our course. Then after that, we basically need to push this direct to our vector, okay? So add course to courses. Yes. So down here, we basically need to do self. Let's do self. Again, we are bringing in self as a mutable object. Take note of that. So we do self.courses dot push. And in this case, we're going to push course. So the course object that we just created. Again, I think we need to push a reference to that and not gain ownership of it. Great. So that is basically going to append an element to the back of the collection. Okay. And yes, that is basically how we go about that. Let's head on to the second function, the get from vector. Now, get from vector is going to basically get items from our vector. But like I said, our item could be containing thousands or hundreds of thousands of items. So if you're trying to get all the items at once, the gas may not be enough to do that. So in some sort of way, we need to think on how we can paginate our responses, or be able to minimize on the number of responses we want returned, right? So let's say we wanted to, let's accept some parameters here. So we're going to specify the start index. Let's accept this as U32. Then we're going to have limit. So limit is basically going to be the number of items we want returned, okay? Let's accept that as a U32 as well. Then down here, let me create a variable here, call it range. Then our range, we're going to take a U32, then invoke the minimum value. So this one is going to accept 2 U32. So we're basically going to pass our limit and our self.courses.length that way. Okay. Courses length, and this one is going to return something of U64. So I think if I pass this as U32, should help me to get rid of the error. Great. So this is basically going to compare between the value provided as limit and the length of these of our vector. So the total items we have, then it will basically give us the smallest value between the two. Then we have we have the start range. So I'll just go here and do for a course in our self.courses, right? For course in self.courses. So we told courses.eta. Okay, great. So in that case, let's create a vector now. This is going to be the Rust standard collection vector that you're going to use to basically store the items that you actually want to return back to the user. So, so let's call this result. The result is going to be to take the vector. Let's just initialize that. So this is going to be of type vec, and our vector is going to contain items of type courses. Should be course. Great. So inside here, we simply want to do result dot push. We want to push course. The index and the course. And now cannot borrow result as mutable because it is now. Oh, I need to have this as mutable up here, guys. Okay, so I hope that is now working. Oh, that was quite mind-blowing. So yeah, that is how we go about it. However, we've not yet made use of our range. So in this case, we need to specify that we're not getting everything, right? We're not getting everything from our vector, but we're getting some within the range, okay? We want to get these things within this particular range. So I think the very first thing we're going to do right here is make some change to our for loop. So instead of using this enumeration, we are basically going to use from 0 to our range. Now from 0 to our range, then we're going to have not really from 0, but from the start. Remember, guys, from our start value, so our start index, to the range. So our range is going to be the minimum plus the start index. So that if we say we're going to start from 0 and we need 5 items, then our range is going to be up to from 0 to 5. If we're going to start from 2, but then we need 5 items, then it means our range is going to run from 2, in this case the start, up to 7. So 5 plus 2 up to 7. Okay, so that is basically what we are trying to do there. Then over here we are getting the index. Let me just call it index for now. So inside here, let's get a course, then assign this to self.courses. Then yes, then just find something from that index. Let's try that out. Okay. Courses, oh no. Courses get index, right? So that is going to give us what? An option, or we can as well unwrap that. Let's unwrap that to get the actual course in that case. So we're getting the actual course. Okay. So after getting the course from our courses vector, we're basically pushing that course object to our result vector down here. Then after that, we basically do what? We basically return our result object. So let me also indicate that in our function signature up here, that we are returning a vector that is going to contain items of type course. Okay, that way. And now it should work quite perfectly, though you could as well, you could still customize this, because we may run into some errors. I'll be showing us as we run the code what we are likely to run into. So that is basically how we do that. Then how do we remove an item from our vector? So we're going to accept a mutable self object at that point. Then we specify, okay, at this point, we're going to specify the index. Let's call this U32. So we're going to specify the index of the item that we actually want to remove from our vector collection. So now let's use self.courses dot remove. So we have swap remove, which removes an element from the vector and returns it. Then we have the remove row, still doing the same thing. So let's use the swap remove, then specify the index. Then within that index, we're going to convert it to U64. So right here, we are told that it removes an element from the vector and returns it. So it means we can as well capture this item that we've just removed in a variable. Let's name this course. Then we basically return that, let's return that value, and also specify that explicitly within our function signature to get rid of the error. Great. So that is basically how we go about removing an item from our vector at a specified index. Okay. So what if we wanted to search for an item in our vector? We would basically do self.courses dot let me see if we have a function to do that. I don't think we have a function to do the search, guys. So we don't have a function to do the search in our vector, unless you decide to go the hard way. So like you loop through the items checking for it. That would really be expensive. Okay. So let me just get rid of this for now. Just get rid of that. Yes. So let's go ahead and build this particular source code to realize our smart contract bytecode and be able to to call these functions that we've just added lately. So I'm first of all going to build it. I'll first of all build that. It happened successfully. Then I'm gonna deploy. Let me see if my deploy file is, yeah, it is well captured. Great. So first of all, it's going to delete, then create the sub account, then finally deploy our smart contract. And that is going to be done in a few. Great. So that was just done. So we're now going to see how we can basically call these functions that we just added to our file. So first of all, we added, let me just have some comments in place to guide us through. So first of all, we're going to add to vector, right? Then you're going to get from vector. Then we're going to remove from vector, right? Great. So let me just have all these commented out, and commented out. So let's see how we can first of all add to a vector. Now the function is, let me get the function. The function is add, right there, add to vec, and it requires the parameter name. So let's capture these I don't know if we are going to have to sign it. Yeah, we'll have to sign it because we are changing the state by adding that data. So near call, we are calling something in our sub account. And then the function we are trying to invoke is that it needs a parameter name, and we're basically going to give it the value computer science. Then from there, we're basically going to sign it using the account ID parameter, specifying our signer. Great. So that way. So let's go ahead and try this out, guys. Let me just comment the previous out. Then let's go ahead and run this in our terminal. So I'm gonna run the call script. Let's see how this is going to unfold. If it is going to run successfully or raise an error. So great. It actually ran successfully. So it returned the empty string because we were not returning any value from this function. And now that we've pushed that, let us just push another element into our vector so that we have two items, right? So we can have software engineering right there. Then also push that. So let's push these. Let's push these. Great. So that was successful. Now, over here, I'm going to get these values or be able to display the content of our vector. So how do we go about that? Let's cover that next. So I'll just copy this command down here and then comment out that. So we're going to have these customized to its taste by replacing the function name. Then our function requires some parameters. So the first one is the start index, then the limit or the number of items you want returned. Okay. So let's just specify this within our call. We're going to need the start, which is not going to be a string, but a number or an integer. So in that case, let's start from 0. So from the beginning. Then let's give the limit as let's get 5 items. So the most we can get is 5 items. Okay, that is basically what that means. Then do we need to sign this particular transaction? Let me see. We don't need to sign it because we are not mutating that, not mutating the state of our smart contract. So we can just call this as a view function call. So let's go ahead and give this a try as well. Let's see if we'll be able to get awesome. So we have an array returned down here. If you're keen, you will be able to see that. Within our array, we have 2 objects. The very first one is the name, the computer science course. Then the second one is the software engineering course. So these curly brackets indicates object or our course objects. So in this case, we only have 2 courses returned. Okay. If we had another one added, in that case, we'd have 3. That would display 3. But basically, that is how we go about that. Now, the third one is going to be, let's look at the third function right here, removing, right? Removing an item from our vector. So let's go ahead and see how this is going to unfold as well. I'll just, okay, let me just have this copied down here. Comment this out. Then this is going to be a call function, a call transaction because we're going to change the state of our blockchain. Yes. And it needs the index parameter. So the index parameter is what is going to specify the index of the object within our vector that we want to remove. Okay. So let's just go that and let's go ahead and capture that within our call. So in this case, we want to remove, let's remove the first course item or course object, in which case that will be at index 0. Then I'll just do away with this other item. Let's go ahead and sign this particular transaction by passing in our signer variable like that. So if I go ahead and execute these, let's see what is going to be displayed to us in our terminal. Again, I can just maximize this. Oh, so there was an error. So it is say my smart contract panicked, failed to deserialize the input from Json, missing the start field. Was it the start field? We're trying to invoke the remove. We're trying to invoke the remove, not get. Oh, please. I think that is where we messed. So let's just give this a shot again. We specified the wrong function name. So let's see what this is going to give us. Great. So it basically returned to us the object or the course object that was removed from the vector. In this case, it was computer science, right? So we expect that next time we run the get function of our vector, this one, we should be able to get just one object within our vector. So let's go ahead and see if that is going to be the case right now. Oh, great. This was quite fast. So you realize that it is returning just one object within the array, okay? The software engineering course object. So that is after removing the other item from the array. So let me just go ahead and let's brush through this. Now, storage staking is the delegation of storage cost to users. Like I said previously, guys, that for every data you're going to store in blockchain, or in this case, in your smart contract, you're going to need to cater for the space occupied with that data. So if your data is going to occupy a certain amount of bytes, then some NEAR tokens out of the smart contract, out of the wallet address where the smart contract was deployed is going to be locked. Okay, so that is going to basically cater for the storage of that particular data in the blockchain. And if you delete the data, then that particular, whatever was locked out of your wallet address will be refunded back or credited back to your wallet address. Now, what if you are coming up with an application like Facebook or Twitter, where you're going to expect people to basically, bring in data, make some comments or likes or put, create some posts and all that. If you're going to come up with such a system, and then you don't implement the storage staking concept, then it means you're going to cater for the storage of all that information. And you can imagine how many gigabytes of data that is going to be. Now, for you to, make this efficient in a way for you as the owner of the system, then you'll delegate the payment to the users. So in this case, for whatever data you're going to store in my smart contract, you'll have to cater for its storage cost. That is basically what storage staking means, okay? Now, this way users pay for the storage of every data they add to the storage in a smart contract. So we've just gone through storages up there. Now, right here is a function I already put in place. So we're basically going to walk through this for us to be able to get the idea behind what's actually going on, okay? So I called this pay for storage, right? The function is named pay for storage. And in our pay for storage function, we're basically going to see how we can implement this functionality where a user pays for the data they've added to our smart contract. So basically how we can capture that within our smart contract. Now, my function is accepting two parameters. Two parameters, one of which is the initial storage. So this is going to be the storage space that was occupied before they added any data to our smart contract, and the attached storage cost. So this is going to be the attached NEAR tokens they are going, or the NEAR tokens they're going to attach to this query. So in our function, we capture current storage. So current storage is going to be the storage after they've added data in our smart contract. okay? Then the storage used is now going to basically be the difference between current storage and initial storage. And maybe just to reiterate, initial storage is the storage before they added data, and current storage is the storage after they added data. And we are getting the current storage using the storage usage method, which we looked at yesterday. Then the initial storage will still make use of this method to capture that. We'll see that as we proceed. Now, after getting the used storage space within our smart contract, so the actual space that the users used within our smart contract, we want to compute how that translates to money or cost, okay? So the very first thing we're going to need to do is get or find the cost per byte in the near protocol blockchain. And like we captured yesterday, this method helps us achieve that. So it will basically give us the price of storage per byte of data in the near protocol blockchain. And again, we are storing that in that variable. Then getting the payable storage fee. So here is how we are going to be able to compute the total storage, or now that you have used this space of storage and we are charging this amount of money per byte, then we basically do what? We take the space multiplied by the price for us to be able to get what you need to pay for the space your data is occupied within our smart contract, right? So that is basically what we are doing down here. We are saying that we're using the storage cost per byte, and we are multiplying, again, checked multiplication or checked mul or checked mule, right? It is basically going to check the multiplication of this integer, and if there's an overflow, it will deal with it, okay? So we do that and we multiply that with the storage used as a U128 integer type. Then the result of that is going to be stored. I don't know if you guys can see this quite well. The result of that is going to be stored in total storage cost right here. Okay. Again, that is coming in is making use of the option enum. So that is how we capture it. So after we get the total storage used, or the total storage cost, sorry, we check if the amount of tokens that the user attached to this call is greater than or equal to what we need to cater for the storage of this data they are adding in our smart contract. Okay, so that is why we are using the assert statement right here. So the assert statement is just establishing that actually the attached storage cost, or the attached near tokens, is greater than or equal to the total storage cost required. Otherwise, we'll basically panic. So by panicking, we'll basically roll back what had happened up to that point to its initial state, then display this to the user, telling them that, hey, there was insufficient funds, so you never attached what was required of you. So if they attached what was required, or whatever they attached was greater than or equal to the total storage cost, then we'll go ahead and process this. And in line 154, where we are checking the balance, we are basically trying to check if what they attached, or the difference between what they attached and what is actually required. It's like going to a shop and you need a bread. A bread costs 60 shillings, but then you have 100 shillings, right? So it makes sense if you get your balance back. You get your bread, yes, but then you're given your balance back because you'll have paid more than what was required. So that is basically what we are trying to capture in this statement. If you attached more than what was required for the storage space, then our smart contract is going to refund you your balance. Okay. So for us to be able to achieve that, we first get the balance of the excess in line 154. Then in line 155, we check if the excess balance is greater than 0. Okay. If it is not, we won't refund you. But if it is greater than 0, then we'll go ahead and return the excess tokens to the user. And to be able to do that, we're going to invoke the return excess tokens method of our contract structure. So let's go ahead and, so in this function, we are basically passing the excess balance that we want to return to the user, okay? And let's see what this function actually does, the return excess tokens function. So right here, it's quite short. So the return excess tokens method basically sends back the excess tokens to the user. And how does it achieve this? Now, first of all, in its signature, we need the excess balance as the parameter. So this is basically the money we are going to return back to the user. So the very first thing we're going to do is get the wallet address of this particular user, because we need to send these tokens to a wallet address. And in this case, an existing wallet address, right? So we're going to capture the wallet address using that statement in line 167. Then in line 170, where we are sending back the excess, we're going to use the promise concept, or the concept of promises. Again, I'll be talking about this extensively tomorrow in our coming session, where we're going to talk about callbacks. Okay, so a smart contract invoking a function in a different smart contract, what we refer to as cross contract calls. I'll expand on that. But for now, this is how we do it. We do promise, then we invoke the new function of that particular object, passing in the signer's wallet address. So in this case, what we just captured in this variable. Then we invoke the transfer method, specifying the amount of tokens that we want to transfer back to that particular wallet address. Okay, so in this case, we are transferring the excess balance, or in this case, the excess amount. Okay, so if you wanted to send to anyone tokens from your smart contracts wallet address, this line of code would help you. It would easily help you achieve that. So that is basically what is happening right there, guys. Now, let's go ahead and see how we can actually make use of this within our smart contract. Okay, I'll head on to our, let's make use of this within our add to map, where we are adding a student object. Now, after getting the wallet address that is signing this particular transaction, I want to get the initial storage, or the amount of space that was occupied by data before this user added their data. Okay, so that is basically going to be, so get initial storage. And I'm going to achieve that. Let me store this here as initial storage. We're going to achieve that using the env module, using the storage usage function right there. So that will give us the initial storage, right? Then the user will basically go ahead, create their student object, and insert that inside the students collection. Then down here, now that they've stored that within the collection, down here, I want to now process their storage information. So this is where I'm going to come in and say self, then invoke the pay for storage right down here, the pay for storage method of our smart contract. Okay, so I'm going to pass in initial storage as captured right here. However, I need to also pass the attached storage cost, or the attached deposit that is going to cater for what? For the storage of this data being added in our smart contract. So how do I capture that? Again, up here, after getting the wallet address, I want to basically get the attached deposit. Okay, so attached deposit is going to be found using this env module and invoking the attached deposit function. that way. It is going to return to us the value of type U128. So this is what I'm basically going to pass down to our function over there. Okay, so if they attached enough near tokens, then that the value is going to be successfully added. But if they attached something less, then that won't be successful. Again, let's just give this a. So that is basically it, how you implement storage staking, guys, what we've just done. But now we want to give it a try, okay, by building this. So let me just go ahead and build this. Let me see if I can do this right here. So clear that out. So the first thing I'm going to do is build this script. That just happened successfully. Then I'm going to deploy. Let's deploy it. Great, that was successful. After deploying, we now want to go back to our call script. Okay, our call script up here. Let me just comment this out for now. Then head back to our our add student command. So we're going to add student, we're going to sign this transaction. However, we need to specify the amount of tokens that we are going to attach. Sorry, guys, I think there's something I missed in my function. For me to be able to attach a near token to this call, then I'll have to explicitly capture it within my function that, hey, this function is going to accept tokens. But as it is right now, this is going to raise some error, because let me just go ahead and show us this before we make the change. So I'm going to specify the amount of near tokens I'm going to attach. Let me attach 2 near tokens, then try to run this script or this command. So this one should raise an error. Great. So here is the error. It is saying that the smart contract panicked. Method add to map doesn't accept deposit. Okay, so that is the default configuration. A method does not accept any attached near token until you explicitly indicate that. And how do we do that? We use the payable macro. Payable. Great. So the payable macro will basically tell our compiler that, hey, this function can accept or is going to accept some near tokens attachment to its invocation. Okay. So I'll again just have to build this down. Let me just build it and compile it. So there's a warning that has been coming up. We have the log here, but then we are not making use of it. So let's just build up that again. Awesome, that just happened. So I'm just gonna deploy again. Great, that was done deploying. So let's go ahead and try and call these. Let's go ahead and call this function. So I've just gone to our call script. Now we're going to try and now call it. Let's call this. Now this time around it should be successful, because I hope we attached enough. Great. So that was successful. Okay, because we attached enough near tokens to it. So if I go ahead and just get student, let's invoke this. If we go ahead and call the get student, should be able to get the student object. There we go. So awesome. That just that went on well. Now up here, I want us to try to store this value, but then attach something less, or even attach 0. Let's attach 0 near, okay, so that we see this in action. Now, first of all, let me delete the object first. So let's first of all delete the object. delete that. Great. So that was deleted successfully. So our key or our wallet address doesn't contain that object anymore. Now I'm going to try to create or store our student object again, but this time around, I'm going to attach no or less near tokens. Okay. So let's see what this is going to give us. I'll just run that script again. Awesome. So you realize that this time around it refuses. Okay. So the smart contract refuses to store that data. Why? Let's have a look at the message right here. So smart contract panicked, and the message was there was insufficient funds. Okay. So we didn't pay for the data we were going to store in our smart contract. So that way the data wasn't stored in our smart contract. And so if I go ahead, let me just comment this out. So if I go ahead and try to view or get the student record, because someone might suspect it might have stored it in the background. Let's see if there's actually an object under that key. So you realize that it returns null. What does this mean? There's no value under that key. Okay, so it basically never added that object to the student's collection. Okay, so guys, again, that is how you go about storage staking in your smart contract. So you can have users actually pay for the data they are going to add to your smart contract, so that you don't have to pay for the space. Now, I said there's a security reason behind that. And what is the reason?
I think whenever users pay, they have access to your smart contract. They interacting directly with your smart contract. I don't know. I think so.
Yeah, it means like if you're going to have a smart contract in place, but then you're not going to implement this within your smart contract, and let's say you have enough money. Let's say you have 1,000 near tokens in your wallet, in the wallet address where your smart contract is deployed, right? So we can have users store data, and when all your tokens have been locked for storage, then your smart contract will no longer function. Why? Because any data coming in, there's no token to be locked for its storage, and so it will keep on failing. Okay, I know you might have heard the attacks or some attacks, the denial of service attack, right? So that can easily someone can easily do that on your smart contract on a blockchain. Okay, if you've not implemented this. So let's say you have a smart contract. It could be a social media smart contract where we just do posting, liking, and all that. So you can come up with a program that is basically going to do what? Keep on adding this data to your smart contract until it is full. Okay, and once that is full, I've been able to put you down. So there's no one else will be able to add data or interact with your smart contract. Okay, those are some of the security perspectives you need to put in place.
Can you have?
Yes.
Can you have a maximum amount of entries? Can you set like limits to it?
Yeah. Now, again, this boils down to how you're going to structure or design your smart contract. So if you don't want to implement the storage staking bit, then you go for limiting. It can still work. So you say, as long as this vector has 1,000 items, I don't want any more items to it. But it is still not proof, or that will still not be approved from the attacks. You'll not have shielded it from the attack I've just talked about. Because if, let's say, you put a limit of 1,000 items, then I just write a script to send those 1,000 items at a go. It means no one will have used your smart contract, because the the vector of your smart contract will already have the 1,000, the limit you specified. So the only way for you to be able to go about or to prevent that particular attack is to have the user pay for the data, for the storage space your data is going to occupy within your smart contract. So that way, it means if I'm going to have this attack or to attack this smart contract, I'll have to pay for the storage of every data I'm going to do what to store within your smart contract. So it doesn't matter how many data I store within your smart contract. As long as I pay for them, your smart contract will still operate without any failure.
Okay, that makes sense.
Yeah.
That makes sense. Thank you.
Great.